are facing, so that our police department can actually face or act on those problems. They want to know which are the problem areas in the city based on social media messages. If somebody says there is a, I don't know how many of you know, but Gurgaon has this bar problem. People start drinking and there are a lot of fights there in a specific stretch of the mall there. So every time there is a high, a party or something, the police would like to know, because at least that beat constable has to know that there is something happening there, so that he can keep an eye out for that. So a lot of this, as I said, the goal is to monitor this social media, to monitor what is there on the web, to understand what are people interested in, what does Ajay Sharma want to do in the next 1 week, so that I can give him that exact thing, so that he gets it, he is happy, and I am happy because he bought it. That's how commerce and retail and everything is moving to today. So how do you now match the correct Ajay Sharma to the Ajay Sharma here? Right? As I said, there are several Ajay Sharmas who can be the bank account holders. Similarly, there will be several Ajay Sharmas on the social media. The name could be A Sharma here, it could be Ajay Kumar Sharma here, it could be, I could write the name with several spellings because of spelling mistakes and several things, but I should still be able to match the two Ajay Sharma. So what do I look for? I look for other evidence. I look for, is this person living in the same place? Now, you could be working in Kolkata and living in a suburb. So your office address will say Kolkata and maybe that will say Howrah or something, right? So how does the machine now know that it's the same person? The address is slightly different because the home and office address, but these are two locations which are still close by. So there is now a space and time aspect now. You're looking at proximity to do the match. How close are Howrah and Kolkata? If the person is working in Delhi and he says his home is Kolkata, very unlikely that these are the two same Ajay Sharmas. But if this person is office Howrah and home in Kolkata, that's very likely. So these are things that the system has to learn. One is, the name variations, geo-proximity, job role. And if I'm a bank, if this person talk about the bank, if this person say that, mention that I'm obtaining great service from the bank, then I'm narrowed down to the Ajay Sharma who talked about the bank. So you're looking for clues, you're looking for attributes. So the named entity recognition problem and the matching problem has now taken a very new sort of a look, as you can see. And here, you've matched these two people, this Mohan and that Mohan who is a IBM employee, with his social media account, based on, even though, the addresses might be looking slightly different or things like that, but you're still matching them based on certain attributes which you think will remain constant. Just like the example we saw of customer, right? The customer, the context of the customer, the words around that word are going to remain the same. So this doesn't, limit itself to just names. If you look at addresses, people can write the same address in several different ways. People can make mistakes. You can have the same name appearing in multiple different ways. So these are all challenges that are faced, and I think in one of the earlier talks, they talked about entity resolution. But here, as you can see, there can be spelling variations, multiple ways in which people can write this. So when you're trying to match two people based on the address, it's very hard, right? If you look at the top three addresses, the first and the third address are the same, But if you look at it, the second and the third look more similar. It's just the J and I. But the J and I make a lot of difference because it's a new block itself. That address is very different from the first one. So the first and third are very similar. I mean, they are the same address, but they look very different. So how does the system learn to do these sort of disambiguations? So how do you assign weights to certain matching portions? How do you learn these weights automatically? Now these are all issues that one has to deal with when you're doing these sort of things. Because it's not a direct match that you can do in this case. Now of course in India there are several other things, we have landmarks behind ISI Kolkata, opposite State Bank of India. So we mention landmarks and several other things, which again cause issues when you're trying to match things. And something like this, that ST there are two different ST. One is street and the other is saint. But how do you determine what is the right ST there? Based on the context. It's the context all the time that's helping you doing the right thing at the right point. So I'll not dwell on this, but how do you decide the match? You can decide based on certain rules, based on certain machine learning methods that you can assign. You can assign certain probabilities to matches, and based on those matches you can do the thing, and then you have to decide where to place the cutoff. That's a common problem. These are not new problems. These are all old problems but in a new setting, right? You're deciding where to do the cutoff, you're deciding where what are the weights for each of the matches. That's what you're trying to do. So in all of this, what are the basic components now? One is, you're trying to do text analytics. You're trying to understand this very noisy piece of information, make sense of it. Secondly, you're trying to do entity integration. You might have said multiple things on social media. How do I combine all of that into one piece of information about what I said? And the final one is entity resolution. Ajay Sharma here, Ajay Sharma here. How do I do that matching? So these are, now you are dealing with these very noisy documents. You're dealing with documents there are errors and all sorts of things, and you're creating this aggregate about this person. That's what this whole thing comes around to, whether it's a person, whether it's an event, whether it's an entity. You're trying to learn about this entity by fusing information from multiple sources and creating the single view about this entity. So these are things that you extract, right? Try to learn where is this person from, what is the age, what is the gender, is this person married, how many kids does this person have, and all of this has to be inferred, right? So you might not say what your birthday is, but if somebody wishes you happy birthday today, then we know that it's your birthday. So that's how you do the inferencing and fill up that column. We determine that you're 30 years old because somebody said happy birthday to you and said happy 30th birthday, whatever. So you now know the date, and that's the kind of inferencing you're doing. So somebody might say I'm from India, but how do you determine this person is from Kolkata? Because this person says that I'm studying in ISI. So how many ISIs are there? You then narrow it down, and then based on maybe your friends, some of whom are from Kolkata or a majority of whom are from here, you then can say with a certain confidence that you're also from Kolkata. So you're basically, aggregating evidence from multiple sources and trying to aggregate this evidence. But remember, you also have to backtrack. Today I might father's name is Raman, based on something I saw on the social media. But tomorrow, if I get more evidence to say that your father's name is Chandra, then I have to backtrack and say that, okay, father's name is not Raman, it is Chandra. And how do I do that? I do that based on the probability assignments and the learning that I do about your different attributes, based on whatever you are saying on social media, on the web, on LinkedIn and various places, and aggregating that across time, over space, and building this profile which is continually evolving. So the goal here is that multiple sources are there, and these sources are giving me some information, maybe conflicting, maybe about the same entity, maybe about the same person, and I want to combine these sources of information, say which of these are more trusted than the others, somehow determine that, and use only the trusted pieces of information to complete that 360 view about. So that's what the whole goal of what I'm trying to achieve here is, right? So whether it is spelling, whether it is the spelling of tomorrow, whether it is to know whether Ajay Sharma is the right Ajay Sharma on the social media, whether it is to know that Ajay Sharma is in Kolkata, whether it is to know Ajay Sharma's father's name is this, or to know whether he is married. For each of these I am collecting information from these multiple sources, fusing them, determining the trust values associated with each piece of information, combining it, and then doing resolution on the different pieces of information that I am. So now what you really want to do is to assign a numerical number to this reliability or veracity, right? Which is very hard to do. The night there was a fire in Mantralaya, the building in Mumbai, that was about a year or two back. The number of tweets from Mumbai talking about the Mantralaya fire, about 200. The same night there were 5, 6, 7,000 messages saying Miami on fire. That night the Miami team was playing very well. It was winning, and all its fans were really happy, and they were all saying, "Oh, Miami is on fire." So you have to be able to understand the nuances and assign these trust values to these pieces of information, because if I have this huge dashboard in front of me, which is really what police departments today have, Gurgaon police, it has this huge dashboard map of Mumbai, Gurgaon there, it knows where its cars are at this point of time because all the cars have GPSs. It is getting information from beat constables saying that, okay, here things are going well, here there was a robbery, so things are showing up on that map. There's an accident somewhere, things are showing up there. Today it's a very manual process. It's based on what people are reporting, it's based on what the beat constables are saying, but the police wants to automate this. How do they automate it? They want to monitor social media. Any message about Gurgaon, they want it to show up on that map. In addition to whatever they are getting, they want this piece of information from social media to show up immediately as soon as it happens. And of course, it doesn't want everything about Gurgaon to be shown, only things which are of police value. So how do you determine what is of police value? You have to make sure your algorithms are able to recognize that piece of information. So here, how do you say that there is a robbery somewhere? If it is coming from a trusted source, if it is a policeman who is saying it, I believe it. If it is a robber who is saying it because he is robbing somewhere else and he wants the police to go to that location, I don't want to trust them. Right? So how assign these trust values, how does the system automatically extract that piece of information and put it on the map, saying that, okay, this message has come from 4 different people, so it must be true. But oh, these people are from the same IP address, so it's not true. This guy is trying to spam. These messages are spread across the city. Maybe even that's not true. How come these people in that corner of the city came to know about a robbery here? So, you have to, these algorithms of trust, of veracity, now have to bring a lot of these heuristics into play. These heuristics are there in the mind of that policeman who typically knows how to say that, okay, this is a true piece of information, this is a false piece of information. That's how intelligence agencies work. They have hundreds of informers, each one of them every day is giving them, saying that, oh, there is going to be a blast there, there is going to be a something there, How does the police know which one to act on? It assigns a trust value inherently to each of these informers. This informer, in the past, he has given me correct information, so he must be correct. This is exactly how stock markets also work. Brokers work like this. They keep getting information from different people saying that, oh, this company is going to, open a new plant, this one is going to do this. Hundreds of messages coming into the broker's office, the mutual fund office, and they have to decide which one do I invest in. So this is information. You're getting information from multiple sources. You have to decide which pieces of information to fuse, which ones to believe, and based on that you have to have a confidence value and then say on top of that how to act. So I'll not go into a lot of the math here because I think you probably understand a lot of this. It's very common probability and statistics, we all learn this. But it's really how do you apply all of this in this new context. A lot of the machine learning algorithms do not scale to Twitter scale data. Why does Google not do natural language processing but just very simple indexing? Because indexing is fast. You can run a query, within a few seconds it gives you an answer. But if you try to ask a question and you're trying to do question answering, it's much harder because you have to do several other things that machine learning, parts of speech, all of these do not scale to large amounts of data. So, this is the UID problem. The UID has 1 billion people in its database. Okay, it's supposed to have. It has the face, it has the fingerprint, it has the address, it has the name. Now I go and try to say that, oh, I am Partho. How do they say I am not Partho? They take my fingerprint, they take my whatever iris, they take my face, they run it through an algorithm. How much can a fingerprint algorithm match to me? The best systems in the world, about 1 million to 2 million in real time. That's what they do. Right? Talking about 1 billion fingerprints. There is no system that today is able to do that sort of matching. Face recognition, again, billion, no, forget it. There is no system that scales to that volume. But if you're matching based on the spelling of the name and address, yes, there are algorithms which can scale to that 1 billion number. So here, what has been done is you're basically fusing these pieces of information. Name by itself, 58% accuracy. Why? Because several Ajay Sharmas. Address by itself, 81%. Why? Because several, we saw some of those. Fingerprint, more accurate. But as you go down there, it's becoming more and more processor intensive. So how is UID going to do the matching problem? They don't know yet, but you know, there are ways in which you can combine a lot of this information you're getting from multiple sources to do that matching. Now, this is something we did for the Philippine general elections. 30% of Filipinos are on Twitter and Facebook. So we were able to analyze for a 2-month period the candidates in their senatorial elections and the Pulse Asia election survey, which is the equivalent of the surveys that our TV channels and everyone does. They were able to predict 10 out of the 12 candidates correctly. So were we. So what that means is, social media is getting closer and closer to what you can do with surveys. Today, you do not have to limit yourself to 2,000 phone calls or 2,000 people going and asking them something. You can actually look at a larger scale. You can look at thousands of people who are saying something on social media and determine based on that what is the positive buzz around the candidate, what is the negative buzz, what are the topics which are of interest to the electorate. Is water of interest? Why did Kejriwal say water and electricity? Because he believes that's the number 1 and number 2 problem of Delhiites. He goes to some other city, maybe Mumbai. Maybe Mumbai doesn't have at least the electricity problem, right?
How would you overcome the skewed demographic nature in India, especially in
In India, it's very hard. I mean, you cannot, because what the
that's the reason.
right.
In the entire India,
You cannot.
Quite impossible.
It is not possible. You're right. But, so that's why certain things are possible. So when, for example, let's say Fair and Lovely, the cream wants to know what are the top 3 things in the minds of Indian women when it comes to beauty, so that they can use those keywords in the ads. They look at social media. They look at what are women in the age group 20 to 25, 25 to 30, the demographics that they are targeting. What are they saying about, clean skin, fair skin, all the other things? And they're picking up those words. Here, how are they doing it? They were actually interviewing women to say, okay, ma'am, what are the keywords that, when I say clear skin, what comes to your mind? Then the lady lists out 5 words. Similarly, they go to 1,000 women and they conduct this survey. Today, what are they doing? They are going on social media and looking at those words. And why is that so? Because their demographics is those people who are there on social media. So there are certain things you can do with social media. There are things you cannot do with social media, like you said. Elections in India, you can't. Maybe in Delhi, maybe. Even Delhi is flaky, but to some extent. Similarly, this is something we did for a real estate firm. They want to know people who are interested in buying property in Delhi, Gurgaon, Faridabad. And what we did was we gave them these leads saying that this person sitting in the Middle East is looking to come back to India. Go target him with an ad for a house. So what you're now extracting is, the names of these people, the sex of these people, the location of these people. Where do they want to look for that house? What is the size of that house they're looking for? What is this person's profession? Is he a media professional? Is he an IT professional? If he's an IT professional, you probably say that, oh sir, these IT companies are right next door to this property. So it all depends on, learning more about that customer be able to target him better to say that if he's an IT professional, he'll go to office and he would want that office to be close to his home. So you tell him that I'm giving you a cheap or inexpensive house, 3-bedroom, you're looking for 3-bedroom, I'm giving you 3-bedroom, which is close to your IT offices which are there in Kolkata. Now this is again that police problem, right? The police typically is looking at 100 number, it's looking at cameras, it's looking at people actually going to the police station, filing FIRs. Now what is it doing? It is actually looking at Twitter, it's looking at Facebook to gain from that power of the crowd, to say that, you know, I don't have to have a policeman everywhere, I don't have to have a camera everywhere. There are people everywhere, and hopefully some of them are telling me about the events that are of interest to me, and I am capturing those, and based on that I am getting an understanding of what is happening in the city. So these are things that, this is something we actually did for the Gurgaon police. Now the police department said people are not, you know, coming and filing FIRs. Even important things like this drinking in the open, police harassment, wrong parking. Can you tell us which are the hotspots in the city? Now here, you know, wrong parking, probably that is the right demographic, because the people with the car probably are also on Twitter and Facebook. Police harassment, well, everyone gets harassed, so that's not a right thing. So in each of these now, as you can see, the goal of the police is to, on that map of theirs, to show up, you know, to say that there, that I'm seeing a parking problem. There, on that map, I'm seeing a drinking problem. That's, you know, they want to see it on their operation center. In addition to whatever else, the earlier information they were getting, they want to monitor social media and everything else to be not surprised, to get that accurate information about what is happening around in the city, so that they can, you know, get that correct information about events and happenings. So I want to, you know, stop here and take any questions that are there. You have any specific? Yeah, go ahead. Yeah, yeah. So I think these are really, of course, there is a technical aspect to these questions, but there is also a very deep sociological and various other, you know, it's a cross-domain sort of a question that you've asked, which I really don't know the answer to, right? Because it's companies, yes, you're right, they want to analyze all that information which is out there, but and they also have very high hopes out of that information, which you're right, probably it's not, it's all hype, you know, maybe you can't get that piece of information from what is there. But the challenge today is that you have all of this piece of information, but you do not have a measure of information value. If you look at what Shannon had, you know, the communication channel. Piece of information going in here, coming out here. The information content, information gain, all of that was very clearly well defined in that space. Whereas here in this space, even though we call all this information, but we cannot put it in that information theory context of channel that we at least know about, right? All the entropy and all those things. So the question you are really asking is, what is the information gain as a result of this new piece of information coming from social media to me, or this new piece of information coming from somewhere else to me? Of course, there is a noise aspect which is very separate, which is also there in that, but it's a very deep question in terms of what is the information gain, and I don't think there is a theoretical basis for any of this right now, and I think the next Shannon-like breakthrough in this space will come when somebody proposes that sort of an algorithm for this space. Yeah, anybody else?
Definite algorithm for find out the sarcastic comment, especially in microwaves like that.
No, there is none. So
What type of methods you try to use to find out the sarcastic comment?
sarcastic comments, one is you can have a corpus of sarcastic comments, non-sarcastic comments, and then you build a machine learning system that tries to learn how sarcastic comments look. But the prior is so high on the non-sarcastic ones, maybe sometimes, that they get hidden somewhere